Hey guys, today we are talking about angles and circles. Alright, so the first angle that we're going to talk about is a central angle. Okay, so a central angle is an angle formed by two intersecting radii such that its vertex is the center of the circle. Alright, so let's look at an example of a central angle. So if this is our circle, and this point right here is our center, if I have two radii, so this is the radius and this is the radius, this angle here would be a central angle. Okay, one thing to know about a central angle is that a central angle so the central angle equals the intercepted arc. So if I said that this angle right here was 80 degrees, that means that this arc is also 80 degrees. Alright, the next angle is called an inscribed angle. Okay, so an inscribed angle is an angle with its vertex on the circle formed by two intersecting chords. Right, so let me show you what that looks like. This is our circle. This is the center of our circle. If you remember, chords go from one point on a circle to another point on the circle. Sorry, that's not very straight. Okay, so we can say that this is point A, this is point B, This is point C. So this angle ABC, is an inscribed angle. And what we know about inscribed angles is that an inscribed angle equals 1/2 of the intercepted arc. Okay, so if we said that this angle ABC is 80 degrees, that would mean that this arc, the arc AC, is 160 degrees. Because this angle, inscribed angle, is half of the intercepted arc. So angle AB, or the measure of angle ABC, is equal to 1/2 the measure of arc AC. So real quick, we're going to look at a special situation involving, actually two special situations involving inscribed angles. Okay, so first case is if we have a circle, and this chord goes straight through the center of the circle, so it's the diameter. And then we have two other chords. So this will be point A, point B, and point C. Okay, if an angle is inscribed in a semicircle, so this diameter cuts the circle in half, which makes this whole part of the circle half the circle, or a semicircle. If an angle is inscribed in a semicircle, it is automatically understood to be a right angle. Okay, and I can prove this by using what we just learned previously, that the angle, an inscribed angle, is half the intercepted arc. Well, the arc here is from this point all the way to this point, which we know if we cut a circle in half, it's 180 degrees. So this arc is 180 degrees. And half of 180 degrees is 90 degrees. Okay? So the other special situation is when we have an inscribed quadrilateral. So this time we have 4 points okay, and this is what is known as a cyclic quadrilateral. I'll write that. Okay, so a cyclic quadrilateral is when it's a quadrilateral four-sided figure is inscribed or inside of a circle, where it's touching the edges of the circle. Okay, and so what we know about cyclic quadrilaterals is that opposite angles are supplementary. So if I took this angle and this angle here, they would be supplementary. So this angle plus this angle equal 180 degrees. Okay, we know that all quadrilaterals are 360 degrees on the inside. So these two would make 180, and then these two would make 180 degrees. Right, the next type of angle is a tangent chord angle. Okay, and that's exactly what it sounds like. It's an angle created by a tangent line and a chord. So if we have a circle, oh, let me make a bigger circle. We have a circle and we have a chord. And then we have a tangent line. This would be, this angle here, would be the tangent chord angle. Okay, just like an inscribed angle, a tangent chord angle is equal to 1/2 the intercepted arc. Alright, so that means if we said that this angle right here was 50 degrees, and from this point to this point is the intercepted arc, so that would mean that this arc was 100 degrees. Okay, so this next type of angle doesn't really have a name, so I usually just call it the angle formed by two intersecting chords, or so the intersecting chord angle. Right, so we have the circle, we have a chord here, and a chord here, and you'll know it's one of these angles because it makes this X, right, and it actually creates 4 angles, 1, 2, 3, 4, okay, so we'll say that this is point A, B, C, and D, and the middle point here we'll say is E. Okay, the angle formed here is equal to half the sum of the two intersecting arcs. Oops, sorry. Okay, so an example of that would be if I was trying to find this angle right here. And I said that this arc AC was 70 degrees. But I said BD was 170 degrees. These two angles are the intersecting arcs of this angle. Excuse me, I meant these two arcs, AC and BD, are the two intercepting arcs of this angle right here. The reason for that is if you remember in the last unit, in the geometry unit, where this created vertical angles. Vertical angles are the same, so this arc, even though this arc goes with this angle, you have to include this arc and this one for this angle. Okay, so if I was trying to find this angle right here, I would take half the sum of these two arcs. So I would do 70 plus 170 divided by 2. So 70 plus 170 is 240 divided by 2 is 120 degrees. So this angle is 120 degrees. Alright, so the next three types of angles are all outside of the circle. They're all angles formed on the outside of a circle. Okay, they're all three different types of angles because they're formed differently, but they all have the same way to find them. So the outside angle is always equal to 1/2 the difference of the two intercepted arcs. Okay, so this formula, the outside angle equals 1/2 the difference of the intercepted arcs, is for all three of the outside angles. So let's look at the first one. The first one is an angle with two tangents. Alright, so we have tangent line here, tangent line here. This will be point A, point B, and point C. Okay? The two intercepting arcs would be from here to here on this side, and from this point to this point on this side. Okay, so both of these arcs together should form 360 degrees because it's the entire circle. Right? If I told you that this, that's another thing, sorry, this bigger arc is known as the major arc. The bigger one is known as the major arc, and then the smaller one is the minor arc. So we have major arc AC and minor arc AC. Okay, and we always do the bigger angle bigger arc minus the smaller arc. So if we said that this side was 260 degrees and this one was 100 degrees, okay, makes sense. 260 plus 100 is 360, it's a whole circle. We can find what this angle is here, because we can say, so the measure of angle B is equal to 1/2 the measure of arc C arc AC. Okay, so it's 1/2 260 minus 100. Which would just be 80 degrees. Right, the second outside angle is with 2 secants. Okay, and a secant, maybe we didn't talk about this in the other lesson, but I'll show you what a secant looks like. So a secant starts at one point of the circle and then continues outside of the circle. So this is 2 secants. Right. Again, same thing, the 2 intersecting arcs. So this angle is half of those 2 intersecting arcs. The intersecting arcs here are AE and BD. If I said that this was 80 degrees and this is 20 degrees, we can find angle C using that. So the measure of angle C is equal to 1/2 the difference, the measure of arc AE, and the measure of arc BD. So 1/2 80 minus 20, which is 60. Half of 60 is 30 degrees. Alright, our last angle is the tangent and secant, so one of each. Alright, there's our tangent and our secant. Alright, this would be point A, B, C, and D. You can say that this is 100 degrees and this one is 30 degrees. We can find this angle. Measure of angle B will be equal to 1/2 the measure of arc AD minus the measure of AC. So 1/2 100 minus 30. So 1/2 of 70, which is equal to 35 degrees. Alright, that is all of the angles that we are going to talk about with circles.